one of the techniques that we use quite frequently in organic chemistry lab is a technique called extraction. And we use it to purify and isolate a product from a reaction typically, or sometimes simply a component of a mixture if you're trying to isolate an unknown or something like that. So I want to show you below here what the idea of extraction is and how you would implement it in a lab type of a setting. So let's look at a little example here. Let's imagine that we have a mixture of, say, two solids. So take a second and let's draw out these two compounds. So this thing is called naphthalene. It is nonpolar, so it would dissolve in nonpolar solvents. And then let's say that we also have in that mixture this compound. Now you've seen this one before. You may have forgotten what its name is, but it is benzoic acid. So we saw it in experiment number 1 where we dealt with solubility. It's also nonpolar. So it will be soluble in nonpolar solvents. So both of these things down below are going to be soluble in nonpolar solvents. So for example, you have things like hexane, right? You have diethyl ether, you could use methylene chloride, so on and so forth. So let's just imagine for the sake of this that we're going to use diethyl ether. Okay, so let's talk about what this process would be. So if we had those two compounds as a mixture, how could we isolate the naphthalene if we were trying to purify it? So let's take a look and see what we can do here. Let's imagine first that we have like a conical vial or something like that. And in that conical vial, you have your solids. And those solids were then mixed with a little bit of diethyl ether, rather. So we'll just put a little line in right here to represent that you have diethyl ether. That's Et2O. And then inside of this, we also have our naphthalene, right? And I'm going to abbreviate this RCOOH, where R is equal to benzene, simply so I could try to fit it in there. And then we're going to call this thing NaPH. Right, that way we can get it in there when we need to try to fit it in. So let's take this solution and let's do this. So remember, diethyl ether is nonpolar. So what we're going to add right now is we're going to add sodium hydroxide. And that sodium hydroxide is aqueous. It means that water is present. So I'm gonna take our conical vial and I want to kind of expand it a little bit here so that I can draw in some levels and you can see things a little bit better. So when we add water to diethyl ether, we form two layers. So this bottom layer down here is going to be your aqueous layer. So that'll contain sodium hydroxide and H2O. That's what AQ means here. And the top layer is going to be your diethyl ether layer. Now when you add sodium hydroxide to benzoic acid, it's going to take away that H atom. Right? So when we add NaOH here, we're going to form RCOO minus. So this is now going to be quite polar because of that negative charge. So now that RCOO minus is going to come down here into our bottom layer. So we get an RCOO minus hanging out down there. Now it doesn't get all of the carboxylic acid out of that ether layer. So we still have a little bit, and I'll just write this up here, a little bit of RCOOH still hanging out up here in the top. And then let's just make a note about that, and let's just say here that there's just a little left. It's trace amount. So you're not going to get it all with one extraction. All right, now in that top layer, you also have naphthalene. That's not going to go down in the aqueous layer because it's a polar solvent down there at the bottom. Now, the technique involves us sticking a pipette in here and pipetting out the lower layer. So as we do that, we're going to come down here and we're going to remove the lower layer. Okay, so that's the technique part where you got to get your pipette and you just slurp it up essentially there. All right, and you take that layer and you put it in another container, so another conical vial or whatever you're using. So down here we're going to have our AQ layer, and then in that solution dissolved you'll have RCOO minus. So remember that this right now is dissolved in the water, right? Now to prove that it's there, what you can do is you can play with that solubility switch, right? And if we were to protonate this, it would become insoluble in water. And the way that we protonate it is you would add something like hydrochloric acid. So you see HClAQ, which is also H3O+. So what happens when you do that? Well, you got your little flask or whatever down here below. You got your aqueous layer here. Now when you add to this, and let's just do that, when you add H3O+, you form RCOOH. And that is now nonpolar. So we're going to get down here RCOOH, but now that's a solid. So what we'll see is we'll see this as a PPT. So you can literally see the solid right there. Now what are you left with up at the top? So you remove that bottom layer. Right, so the top layer remains up here. Right? So we'll come down a little bit lower. Again, that's your diethyl ether layer. And what we set in there before was RCOOH and naphthalene, right? And we said that this was a trace amount. Well, we can get rid of that if we do another sodium hydroxide extraction. So what we're going to do is we're going to take this top layer again, and we're going to add another, we'll just say here, a second aqueous sodium hydroxide extract. We're going to get a repeat of what we saw a couple little flasks ago. So you're going to have a top layer, a bottom layer. Do you guys remember what's the top layer? It's the least dense. So diethyl ether has a density of about 0.78. And down here we have our aqueous layer. And again, we're going to have RCOO minus down here, and at the top you have your naphthalene. So what we've done by doing a second extraction is, in essence, we've removed that trace amount here by performing the extraction twice. Now sometimes you have to do this 3 times or 4 times. In most of our experiments that we will carry out when we do this type of extraction, it's usually just twice. Now what we would do is we do that same thing. So you stick a pipette in and you pull off that bottom layer. And what you're left with then is a repeat of what you see on the other side here. So same idea, right? Here you have your aqueous. Here you have RCOO minus. And to see if it's present, you would add H3O plus. So when you do that, you're going to have your aqueous solution up here, and then you'll have RCOOH solid down there below. Now, typically what we do is, rather than write it out twice like this, because we just kind of, right, if you look at it, we repeat it, right? So this is a highlighter, but this part right here is the same as this part right here. So what we do is we indicate that we do this twice by writing above this first extraction right here, this. We write 2 times. And that way we can basically ignore writing this guy out, right, a second time, because it's just a repeat. Okay. Now, when we look at the final solution here, and we talk about our top layer, so here's your conical vial or whatever you're dealing with. You have your ether layer here. You have naphthalene present. Now, to get that out of solution, what we do is we do 2 things. So it turns out that when diethyl ether comes in contact with aqueous layers, like right here, they're in contact in the surface, right? They're touching each other. When that happens, a little bit of the water comes up into that top layer. So we actually have here a little bit of H2O trace. So we could get the naphthalene out of solution if we just evaporated the ether, but with trace water, you'll evaporate the ether and then you'll be left with water. That's not the end of the world. It just takes time, right, to evaporate water. Ether evaporates very, very quickly. So what we do is we first dry, right, our ether layer with sodium sulfate. So sodium sulfate wants to form a compound called sodium sulfate decahydrate. So we dry it, and when you put that in, there's like a process to it. You put usually like a spatula full in there, and you see if it clumps together. But here you'd have your naphthalene, and then what you'd see down here at the bottom is, right, like this solid that forms in there. So that's going to be, so the Na2SO4, by the way, is a solid. But that's a solid that has Na2SO4 dot up to 10 H2O. It's a decahydrate there. So we're almost done. In order to purify our compound, you do a few things, and I'll just highlight this here for you. So number 1, you remove the solid Na2SO4. We usually do that by just pipetting it into another test tube or something like that. So we'll call this like via transfer. Okay. At that point in time, then you evaporate diethyl ether, and then when you're done, you're just going to have your, probably, you transfer it to a test tube or something like that, but you're just going to have here your solid naphthalene. And then what we would do is we would take its melting point to see how well we purified it.